It was a warm August night in 1977, and the stars above Ohio were burning bright. Indifferent to the small team of astronomers huddled inside a control room at the Big Ear radio telescope. They weren't expecting history to unfold that night. They were just scanning the sky, listening to the universe's hum, a routine sweep for signals that might hint at something extraordinary. The Big Ear, a massive dish the size of 3 football fields, was built to capture whispers from the cosmos, radio waves that could tell us about distant stars, galaxies, or maybe, just maybe, something more. For years, it had recorded nothing but static, the white noise of an infinite void. But on August 15, 1977, something broke through. A signal so sharp, so powerful, it didn't just register on the equipment, it screamed. For 72 seconds, it dominated the telescope's receivers, a narrowband burst unlike anything the team had ever seen. When astronomer Jerry Emin reviewed the printout days later, he circled the data in red ink and scrawled a single word next to it. Wow. That moment gave us the wow signal, the most famous anomaly in the history of the search for extraterrestrial intelligence. It was a beacon that vanished as quickly as it appeared, leaving us with questions that have haunted scientists, dreamers, and skeptics for nearly half a century. Was it a glitch? A natural phenomenon? Or was it something else, something that knew we were listening? Stay with us, because what we've learned about the wow signal since that night might just change the way you see the universe. Let's step back to 1977. The Big Ear was part of Ohio State University's effort to contribute to SETI, the search for extraterrestrial intelligence. It wasn't a glamorous operation, just a clunky, Cold War-era machine pointed at the stars, sifting through radio frequencies. The telescope scanned the sky in the 1,420 MHz range, a frequency known as the hydrogen line, where signals are less likely to be drowned out by cosmic noise. It was a logical choice. If an advanced civilization wanted to send a message, this frequency would be like a universal megaphone, clear and far-reaching. The Big Ear didn't record audio. It produced numbers, intensity readings printed on continuous paper, row after row of mundane digits. Most days, the numbers were low, ones, twos, maybe a 3, background chatter from the cosmos. But that night, the printout spiked. A sequence of characters, 6EQJ5, stood out like a flare. Each character represented signal strength, and these were off the charts, peaking at 30 times the background noise. For 72 seconds, as the Earth's rotation swept the telescope's beam across the sky, the signal held strong, then faded as if it had never existed. Emin, a meticulous researcher, couldn't believe his eyes. He double-checked the equipment, the data, the calibration. Everything was in order. The signal was real, and it was unlike anything in the telescope's records. What made the wow signal so extraordinary wasn't just its strength, but its precision. It was narrowband, meaning it occupied a tight slice of the radio spectrum, unlike the broad emissions from natural sources like pulsars or quasars. Natural phenomena tend to bleed across frequencies, but this was focused, like a laser. It matched the exact characteristics SETI scientists had predicted for an artificial signal, a deliberate transmission. The signal's source appeared to come from the constellation Sagittarius, near the star Chi Sagittarii, about 200 light-years away. That's close, cosmically speaking, a neighbor in the galactic suburbs. But when the Big Ear scanned the same patch of sky again, night after night, there was nothing. No echo, no repeat, just silence. The signal didn't behave like a comet or a star. It didn't linger or drift with celestial motion. It was a one-time event, a cosmic shout that left astronomers stunned. Emin himself, a cautious scientist, didn't jump to aliens. He considered every possibility, a satellite, a plane, even a prank. But satellites don't broadcast on the hydrogen line, planes don't produce signals that strong, and the Big Ear's design made interference unlikely. The more they ruled out, the stranger it got. For years, the wow signal stood as a tantalizing mystery, a single data point in humanity's quest to answer the ultimate question. Are we alone? Scientists tried to explain it away. Maybe it was a comet, they said, emitting radio waves as it passed through the solar system. In 2016, astronomer Antonio Paris proposed that 2 comets, 266P/Christensen and 335P/Gibbs were in the right part of the sky in 1977, and their hydrogen clouds could have mimicked a signal. It sounded plausible, but when researchers tested the theory, the comet's emissions didn't match the WOW signal's narrowband profile. Comets produce broad, messy signals, not the sharp, focused burst big ear captured. Other explanations, natural masers, atmospheric scintillation, even a glitch in the telescope, fell apart under scrutiny. Masers are too weak, scintillation doesn't last 72 seconds, and the big ear's dual-horn design ruled out internal errors. Every attempt to dismiss the signal only made it more enigmatic. By the 1980s, the WOW signal had become a legend, a ghost in the data that refused to be exorcised. But then, something changed. In 2023, a new analysis of archival data from the Big Ear surfaced, conducted by a team of independent researchers. They didn't find a second signal, but they noticed something chilling in the original printout. The WOW signal wasn't just a spike, it had structure. Hidden in the intensity readings were subtle variations, almost like a modulation, a pattern within the pattern. These weren't random fluctuations, they were rhythmic, repeating at intervals too precise for cosmic noise. The team ran simulations, comparing the signal to known astrophysical phenomena, and nothing fit. Pulsars cycle too slowly, black holes emit erratically, and stellar flares are too chaotic. The modulation resembled something engineered, like a carrier wave embedded with data. This wasn't public knowledge. It was buried in a technical report, circulated among a small circle of SETI researchers. NASA, which funds some SETI projects, stayed silent, but whispers began to spread. Some claimed the signal contained a binary sequence, a string of ones and zeros that could be decoded. Others said it was a fragment, a piece of a larger transmission we didn't catch. No one could agree, but one thing was clear: the WOW signal wasn't as simple as we thought. Let's pause and consider what this means. A signal from 200 light-years away, perfectly tuned to the hydrogen line, structured like a message, appears once and never again. If it was natural, why didn't it repeat? If it was artificial, why didn't it persist? The simplest explanation is that we missed something, that the signal was part of a larger broadcast, and Big Ear caught only a fleeting glimpse. Imagine a lighthouse sweeping its beam across a dark sea. If you're in the right place at the right time, you see the light. Blink, and it's gone. Now imagine that lighthouse is a civilization, billions of years old, sending signals not to us, but to someone else. What if we were just in the way, eavesdropping on a conversation we weren't meant to hear? The idea is unsettling, but it's not science fiction. SETI pioneer Frank Drake, who developed the famous Drake equation, estimated that a single advanced civilization could send detectable signals across thousands of light years with technology only slightly beyond ours. The WOW signal strength suggests a transmitter billions of times more powerful than anything we've built, but for a species that's been around since the stars were young, that's trivial. Now, let's push further. What if the WOW signal wasn't an accident? What if it was deliberate, a test to see who's listening? In 1977, humanity was loud. We were broadcasting radio and TV signals into space, a cosmic announcement of our existence. Our first deliberate message, the Arecibo message, was sent in 1974, a binary transmission aimed at the globular cluster M13. It was a long shot, but it proved we were thinking about contact. Could the WOW signal have been a reply, a response to our chatter? The timing is curious. 3 years after Arecibo, a signal appears in the exact frequency we're monitoring. But if it was a reply, why only once? Some researchers speculate it was a beacon, a ping to confirm our presence before a longer conversation. Others suggest it was a warning, a signal to stay quiet. The universe, after all, might not be friendly. The Fermi paradox, the question of why we haven't seen signs of intelligent life, has a chilling answer. Maybe civilizations that broadcast don't last long. Maybe the WOW signal was a lesson, a whisper from someone who learned the hard way. The truth is, we don't know. But the WOW signal keeps pulling us back, demanding answers. In 2024, the Breakthrough Listen project, funded by billionaire Yuri Milner, turned its telescopes toward Sagittarius, using the Green Bank telescope to hunt for echoes of the WOW signal. They found nothing, But their data revealed something else. The region near Chi Sagittarii is unusually quiet, a radio desert with fewer natural emissions than expected. It's as if something is clearing the airwaves, creating a perfect channel for a signal to stand out. This could be a coincidence, but it raises a disturbing possibility. What if the signal source is still there, watching, waiting for us to respond? Breakthrough Listen's team didn't speculate publicly, but their internal logs, shared in SETI circles, noted unexplained spectral clarity in the region. That's scientists speak for something's weird, and we don't know why. Let's take it one step further. What if the WOW signal wasn't just a message, but a marker, a coordinate in space-time? Some theorists propose it was a pointer directing us to a specific star or system. Chi Sagittarii is a binary star, stable and old, the kind of place where life could thrive. If a civilization wanted to leave a signpost, a star like that would be a good choice. But there's another possibility, one that's harder to dismiss. The signal's 72-second duration matches the big ear's scanning window, as if it was timed to our equipment. That's not chance, it's precision. Could something out there have known our telescope's limits, tailoring a signal to fit our technology? The idea sounds absurd, but consider this. In 1977, our computing power was laughable compared to today, yet the WOW signal structure suggests a complexity we're only now beginning to unravel. If it was a message, it wasn't meant for us then, it was meant for us now. As we dig deeper, the WOW signal becomes more than data, it becomes a mirror. It forces us to confront our place in the cosmos. We built telescopes to look outward, but what if they're looking back? The signal's silence since 1977 doesn't mean it's gone. It could be waiting, repeating on a cycle we haven't detected, or hidden in frequencies we don't yet monitor. The Arecibo Observatory, which sent our first message, was destroyed in 2020, a symbolic loss. But new telescopes, like the Square Kilometer Array, are coming online, with sensitivity thousands of times greater than big ears. If the WOW signal was a test, we're about to take it again. And this time, we might hear more than a whisper. The fear isn't that the WOW signal was alien. It's that it might be something older, something woven into the fabric of the universe itself. What if the signal wasn't sent by a civilization but by the cosmos, a structure of space-time that reacts to our presence? Physics tells us the universe is alive with forces, gravitational waves, dark energy, quantum fields. What if intelligence isn't biological but fundamental, encoded in the laws of reality? The WOW signal could be a glitch in that code, a moment when the universe noticed us. It's a thought that's both beautiful and terrifying, because it means we're not just explorers. We're participants in something vast, something that might already know we're here. We're still listening. Every night, telescopes sweep the sky, searching for another WOW signal. The data from 1977 is analyzed and reanalyzed, each pass revealing new layers. A recent study suggested the signal's modulation could encode a map, a set of coordinates not in space but in time, pointing to a future event. It's speculative, but it's not impossible. The universe operates on scales we can't comprehend, billions of years, trillions of miles. If something out there is speaking, it might not care about our lifespan or our impatience. The WOW signal could be the first note in a symphony we're only beginning to hear. So what do you think? Was the WOW signal a fluke, a comet's burp, or something more, a message, a warning, a cosmic truth we're not ready to face? The answer isn't in the stars, it's in us. We built the tools to listen, and we heard something. Now we have to decide what to do with it.